This video is going to talk about Graham's Law of Effusion and about how fast different gas particles effuse or go through a small hole. Okay, Graham's Law of Effusion says that the rate of A over the rate of B is equal to the molar mass of B over the molar mass of A, and of course taking the square root of the molar mass. Important thing to notice here is that the RB is opposite of where its molar mass is. And RA, the rate of gas A, is diagonal from the molar mass of A. So you have the rate of A over the rate of B equals the square root of molar mass B over molar mass A. Do not forget, those are diagonal across from each other. Okay, we also sometimes have to relate time instead of rates. A gas effused in 3 seconds. So this time the difference is, notice that we have time B over time A equals the square root of molar mass B over molar mass A. So this time it's not diagonal. The time of B is straight across from the molar mass of B, and the time of A is straight across from the molar mass of A. Okay, so here would be a problem. What is the rate of effusion of hydrogen to nitrogen? Some people have a lot of problem with this one, and it's meant to be just a simple problem where you're finding the ratio. So I really want to find the ratio of the rate of hydrogen over the rate of nitrogen. So I'm comparing the hydrogen to the nitrogen. Notice that the nitrogen's mass is on top, so it's diagonal across, and hydrogen's mass is on bottom, and so it's diagonal across. Divide the 28 by the 2.02, take the square root, and we get 3.9. What this tells us is that hydrogen effuses 3.9 times faster than nitrogen. Now this should make sense because we said that the lighter the atom was, or the molecule was, the faster it would effuse. It'll travel faster, and it's smaller, so it's easier to go through the hole. So the lighter the atom or molecule, it's going to travel much faster than heavy molecules. So that's why 13.9, hydrogen effuses 13.9 times faster than nitrogen. Okay, another practice problem. At room temperature, xenon atoms have an average speed of 240 meters per second. At the same temperature, what is the speed of hydrogen molecules? So we want to use the rate equation, and since I'm trying to find the speed of hydrogen, I'm going to put it on top. So just for my unknown is on top, which makes it easier. So I'm trying to find the rate of hydrogen over the rate of xenon, which would be equal to, this one we don't know, it's x, and the xenon we do know is 240 meters per second. Now that would be equal to the square root of x, the rate of xc is on the bottom, so the molar mass of xc is going to be on top. So you simply look at the periodic table to get the mass, and it is 131.29. And up on top here I have hydrogen, so I need the molar mass of H2 on the bottom, so it's approximately 2.02 grams per mole. Grams per mole over grams per mole is going to cancel. We'll be left with this meters per second out here. So now what we do is we divide 131.29 by 2.02. That gives us approximately 64.995. And then we want to, which is still equal to our x over 240. We want to take the square root of that and multiply it by 240. And that will give us a final answer of about 1,934. But we're going to round it to two significant figures because the 240, which makes it 1,900 meters per second. Okay, so that's how fast hydrogen is going to travel effuse through the hole. It's going to travel 1,900 meters per second. That's really fast. Okay, another problem. A different type of problem. Krypton atoms effuse through a hole in 10.8 seconds. How long would it take for neon gas to effuse through the same hole under the same conditions? So this time we're not dealing with rates, we're dealing with time. So this time we need to use time straight across from the molar mass. Now the time we don't know is neon, so we're going to put the time of neon to fuse at the top, and we're going to put the time for Kr to fuse on the bottom. And then for that we're going to do the square root of, remember that's straight across, so we're going to put the mass of neon on top, which is 20.179 grams per mole. And the mass of krypton on the bottom, 83.80 grams per mole. And of course that is equal to X, which we don't know, times 10.8 seconds. So now take the square root of 20.179 divided by 8.30 and multiply it by 10.8, and we get 5.30 seconds. Okay, so does our answer make sense? It's always really good to think about that. Neon is lighter than krypton, so it traveled faster. 5.3 is faster than 10.8 seconds. So the lighter it is, the faster it's going to travel, so our answer does make sense. Okay, a different type of problem. This one for some people can be the most confusing, but it's really not any more difficult. This one is finding a molar mass of an unknown gas. So what is the molar mass of a gas? If it diffuses, which this actually should be effuses, because we're talking about effusion, not diffusion. Diffusion is gases mixing throughout the room. Effusion is going through a hole. 0.907 times the speed of argon gas. Okay, so our gas is slower than argon gas. How do we know that? Because it's a less than a 1 ratio. So that means our gas must be moving slower than argon. Now, we're talking rates here. So we're going to have the rate A over rate B is equal to the square root of molar mass B over molar mass A. Now, what should I call A and what should I call B? Because I'm trying to solve for the molar mass, I always like the whatever we're solving for on top because it makes it easier. So I'm going to say the molar mass of our gas, the one we don't know, is going to be on top, which means that the rate of our gas is going to be on the bottom. Remember, our gas is 0.907 times the speed of argon, so 0.907 has got to be across from that, and then a 1 on top, because that's what it's comparing. 0.907 of our gas compared to 1 of the other. And then we want the molar mass of the other gas, argon, across from the 1 on bottom. So the mass of argon is 39.948 grams per mole. Okay, so to solve this, we're going to take 1 and divide it by 9.07, and we get 1.1025. We need to get rid of the square root right here. To get rid of the square root, we square each side, so that will cancel the square root out. So we're left with molar mass of our gas is equal to 39.948. So square 1.1025 multiplied by 39.98, and we find out the molar mass is equal to 48.6 grams per mole. All right, those are the main kind of problems that you'll run through in effusion. Don't forget to work on your worksheets and take the online quiz.